Let's begin with the purification of organic compounds. So we need to purify the elements, the compounds, the whatever, maybe some colors we need to separate. So the entire topic actually should be framed as purification and separation techniques. Now, this is most relevant because when we go to the actual field, there might be, or if you do not even go to some lab field, some chemistry field, or some industrial field, but rather you go to your kitchen and by mistake you actually mix water with oil, what do? In those cases, what will be helpful will be such techniques. So we should know all of these techniques. Let's see. It's the removal. What is purification? Removal of the undesirable impurities and to bring things in the pure state. So we are trying to now do the purification techniques. One such technique coming your way is crystallization. As a class 8 student only, you start knowing about crystallization. You can take impure copper sulfate and you can carry out crystallization and get that pure, beautiful blue color crystals. Okay, so here we have crystallization process coming up. After the NEET examination will be over, I'm planning to bring this series of teaching chemistry from the series of the Breaking Bad, which I am planning to do on Rasayan Pryogshala. So let's see if chemistry takes a different turn where it doesn't feel like a boredom, very difficult subject, and just the NEET and JEE syllabus, nothing else. Nothing else. But we can learn from there. Like there is one beautiful question that has come from that first season itself. Okay, by the way, crystallization is based on the principle of solubility of compounds. First type of questions, guys, which are possible from such topics are the principle questions. Like what's the principle behind distillation? That the boiling point, we are making use of the boiling points, that there are differences in the boiling points of the two different compounds. And that boiling point difference should be appreciable. Here we are making use of the solubility. What is it? Solubility of compounds. Solutes tends to be more soluble in hot liquids than in the cold liquid. This is the principle. Okay. Now let's talk about all the different types of distillation, for which you were asking for a trick. There is no trick, you have to know it. So the first type of distillation is simple distillation, which is very simple, wherever there is a difference of the boiling point, which is appreciable boiling point, 20 degrees Celsius plus. So if there is A with, let's say, 80 degrees Celsius and there is B, let's say 140 degrees Celsius, how can we separate the two? Let's make use of distillation. Then there is fractional distillation. Whenever the difference is not going to be so much. Whenever the difference is less than 20 degrees Celsius, we can make use of the fractional distillation. One very common example is your fractional distillation of the crude oil. How you get petroleum, and when you do the crude oil fractional distillation, you get different columns. And because there are different columns, different fractions, that's why the name fractional distillation. So this is also sorted. Third one is vacuum distillation. Now, where are we going to make use of the vacuum distillation? Let's say before reaching the boiling point, something is decomposing. Like glycerol. Glycerol, before reaching its boiling point, will become decomposed. How will you separate glycerol if it is already decomposed? This we make use in the soap industry. So please note, vacuum distillation for anything which decomposes before its boiling point. So what you can do vacuum distillation. How will that help? Yeah, vacuum, the spelling is also quite interesting. For the longest time, dictations were asked from the spelling of vacuum, V-A-C-U-U-M, not V-A-C-C-U-M-E or anything else. What should be the pressure? Pressure, can I say, is almost zero? Yeah. So can I also say that if pressure is decreasing, what will happen to the boiling point for the same volume? If volume is constant, do you know which law can we apply if volume is constant? If volume is constant, I made you remember, I think, all the laws that are that were earlier a part of your states of matter, GV, right? So we can say GV, Gale-Lussac law, volume constant. You can remember the trick, BT, Boyle's law, temperature constant. CP, BT, bad trip. CP, Knot's place. Charles' law, pressure constant. GV, Gale-Lussac law, volume constant. ATP, adenosine triphosphate. ATP, Avogadro law, temperature and pressure constant. You can imagine a piston and start imagining whatever is constant, change the other two variables and you will be able to figure out the relationship. So if the volume is constant, if pressure decreases, so does the boiling point. So let's say if glycerol had a boiling point of 360 degrees Celsius, now because we have reduced pressure so much, the boiling point also reduces. So at 180 degree only, you can extract all the glycerol. Is it clear when to use vacuum distillation? The last one is the steam distillation. So we want to, whenever extract any kind of oil, all these oils which are coming in the market right now, the castor oil, the almond oil, the ones which are extracted through the distillation process, they are carried out through steam distillation. We don't want any attractions between the water and the substance that we are trying to isolate. So in such cases where oil's extraction is required, we can make use of the steam distillation, as simple as that. This sums up all the 4 different types of distillations. Okay, let's quickly now go through them. So you can see that simple distillation, when do we apply it? It is applied for only volatile liquids which boil without decomposing at the atmospheric pressure. We don't want decomposition, because if decomposition is happening, vacuum distillation. That's how easy it is. It can also be used for separating liquids having sufficient difference. This is the main point, by the way, right? So here you have the examples, benzene and aniline. If I want to separate, can I make use of the simple distillation? Why not? Why not? You can see 80 degree, 184. Chill case. Easily you can extract benzene and aniline will be left over. Okay, chloroform and aniline. Quite a good difference. Okay, let's make use of the simple distillation. This is how the setup looks like. It is important to know that we have inlet and outlet at what positions. We are taking round bottom flask, we are heating, we have water acetone mixture, the round bottom flask, everything is here in front of you. Please see. The questions can also be apparatus related. They can be apparatus. Which of the following is an apparatus of round bottom flask? Again, something which you would see in Breaking Bad, where this guy was making use of conical flask. He was making use of a flask which is a volumetric flask for creating these crystals, and actual apparatus which should be used is this round bottom flask. Okay, so yeah, here we have round bottom. If it is not round bottom but it is like this, okay, one is a volumetric flask, but if it is a little flattened from the base, we call it gel-dahl flask. So gel-dahl flask is different from round bottom. You should know this. Last year only you got, last year you have got questions related to the apparatus. The question which came in 2023 was, which of the following is separating funnel? So you should know how a separating funnel looks like, right? Okay, moving ahead now, you can see that what you have here are the inlet and the outlet. So this is your outlet. Water is coming from up, inlet is down, because we do not want any gap to remain at the top. So if you're due for your practical examinations, this is the favorite question of the Viva. Why is outlet on the top, inlet at the bottom? We want water to actually, we want it to stay cool from every place. We don't want that it enters from here and exits from here. We are also knowing a little bit of physics. We chemists are not just so blind with the physics part that we forget that if there is a hole from where the water can go, then it will just cover that portion. No, the top part and the bottom part might be left without water. And what would that do? If it is left without water, it will become extra hot. Imagine we are bringing up temperatures up to 350, 380. Imagine such high temperatures. So the glass will blast. It can come into your eye, it can penetrate when it blasts, so it can create huge problems. We don't want that. Make sure that inlet and outlet are at the right positions, outlet up, inlet down. What you're getting now here, whatever is the lower boiling point, mixture with the lower boiling point, will be received in the receiver flask. Okay, so water acetone mixture we had. So acetone has lower boiling point. So here should we have acetone, and here we should have liquid water. How the examiner can ask such questions, very generic questions, are actually which are the questions related to the boiling point. They will ask you what will be received in the receiver flask. So trust me on this, if I had to set the paper, I would give very simple questions which requires you to think a bit. No cramming, nothing, just some application. So that means what you will receive in the receiver flask will be that species which has the lower boiling point as compared to the other substance which you are taking in the mixture, right? So such questions can be asked. Okay? Okay, so now we are on fractional distillation. Talk of the devil, and devil is here. Okay, so what is fractional distillation? You will have fractionating column. Check. So examples are, check the examples. Can you tell me the difference here, 65 and 57? Do you see? That's quite lesser difference. Hello? And that is what the condition was. I told you that fractional distillation becomes meaningful only when the difference is not a lot, right? 80, 90, 100, 110, like 30-degree difference. But yeah, what we are making use of here also is the fractional distillation. We don't want to miss on anything. So you can see there's a column here. Check what we are trying to do. We have the setup in front of us. You can see we are taking oil bath to maintain. We are taking water ethanol. We do not want ethanol to catch fire. So to avoid ethanol catching fire, I'll get this side. To avoid ethanol getting fired, getting all blown up here, we are taking oil bath. Vapors are being observed. You can see fractional column with the glass beads to provide the condensation, so that now we can separate easily ethanol from water. So of course you have water outlet and inlet in the same manner like how we discussed. Taking water ethanol, ethanol has a lower boiling point, so it will be ethanol. Now you're telling me. So ethanol will be collected in the receiver flask. Okay, great. So distillation, I gave you one example. So compounds which decompose before their boiling point is reached. This one is simple. This one is OG. This one is simple to grasp. Okay. So distillation under reduced pressure is another name of vacuum distillation. Point to be noted, my lord. Do not miss this fact. Simple fact can be asked. Okay. So we have, I told you, like for example, glycerol, which actually has a decomposition happening before its boiling point, which we make use of in the soap industry. I hope you know that glycerol, we make it react with, that's the alcohol part. We make it react with the acids. Remember, what you get is a triglyceraldehyde. What you get is, if you remember, this is there in all the fats, all the oils. The esterification reaction takes place between alcohol and the acid, and what you get are the fats, which are triglyceraldehydes. So that is also in the soap industries that we make use of, the saponification reaction, which is opposite of the esterification reaction. We make use of this vacuum distillation, and glycerine can be distilled at 180 degree. Boiling point you can check is 280 degree at lower pressure. Okay. I think I've shown you one example of this. I'll send it to you again. So the chemically right name is actually glycerol. It is sold in the market. The bottles that you get is of the glycerine. Okay, they're same. Both are same. Please point to be noted, my lord. Glycol is actually the one with the two OH groups, which we call as ethylene glycol. So yes, please point to be noted, my lord. These are essentially the same stuff that we are talking about. CH3OH groups. If you just take glycerine and take powdered KMNO4, there will be fire. There will be instant fire. That's how strongly oxidizing KMNO4 is. Okay. How many OH? Oh, 3 OH. All right. Next one, please see. I'm avoiding this part. You can observe how the whole setup is going to look like. There is just the vacuum attached to it. That's it. That's the only difference. Everything is the same. It's just a vacuum that we have now attached to it. Next one is the steam distillation. Now, like I told you, any extraction of oil is carried out through the steam distillation, and that really sorts your life, because there was once upon a time a question on how was the extraction of turpentine oil carried out. This asked turpentine oil. Another time they asked a question how the extraction of castor oil happens. Another question. Now next time they might ask how do we extract rosemary oil? How do we extract jojoba oil? How do we extract? They can give you all the night routine oils and can ask a question. Okay, coconut oil, any oil, right? So in steam distillation, the liquid boils when the sum of vapor pressure due to the organic liquid P1 and that of the water becomes equal to the atmospheric pressure. So this is what happens in the steam distillation. These are the examples. You can make use of these: ortho, meta, para, chlorotoluenes, ortho, para, nitrobenzene. So that means you take them with water and you allow you allow this distillation to happen. What you will get, all the impurities will stay. What you will get is going to be that particular thing. Because it is not mixing with water, you can get it in the receiver flask and easily separate. Okay. Now we will enter differential extraction. I am telling you, every apparatus which is coming your way is very, very crucial. So here you will be seeing separating funnel. Okay, so this is the process of separation from its aqueous solution by shaking with a suitable organic solvent. So here we are actually going to make use of the difference of the solubilities once again. So the solvent should be immiscible with water and the organic compound should be separated and should be highly soluble. Let's just understand with an example. Benzoic acid can be extracted from water solution using benzene. So what we are going to do is, look at this. This will make your life easy. Look at this. This is your separating funnel. Are you able to observe the shape? What you have added? Check it once again. So you have the separating funnel. You have compound A in aqueous layer. This is an aqueous layer that you have. You're adding now an organic layer. So aqueous layer and organic layer will not mix, just like how oil doesn't mix with water. So this was the water layer and this is the organic layer. Organic layers are usually lighter. Their density is usually lighter. So they will stay on the top. This was compound A in the aqueous layer, right? There is some compound in this aqueous layer. But when you shake it now, when you do the shaking, after vigorous shaking, you will see that now entire compound A has gone to the organic layer. So you can see you have separated the compound from the aqueous layer and collected it in the organic layer. Now all of it, the compound A is in this particular layer. So this is what you are doing. You are simply separating. And now from this organic layer, it can easily be separated by carrying out simple methods like distillation once again. Okay. Or if I simply ask you questions related to how can I separate oil from water, what you can do is you can make use of separating funnel. So by mistake, if in kitchen this mixing happens, make use of separating funnel. You can always remember how the questions can come. Questions will be about the density here, which can be an applicative part of the density. So the lower layer will always be the aqueous layer. The organic layer will always be the upper layer. Usually we make use of such funnels, such separating funnels for carrying out separation when there is substance which can dissolve in a which is already dissolved in water. We are unable to separate it because there is a strong hydrogen bonding with water that has taken place. We are not able to remove it. So what we can do, we can make use of this kind of a separation. Take an organic layer, shake it, it will come to the organic layer. So we have separated the water. All right. Now we can talk about some more questions related to this. The whole apparatus is very, very important, and the precise examples coming your way are also very, very important. Okay. Chalo, moving ahead now. Chromatography. Again, a very important part. Chromatography is one of the very important areas from where the question can come. Hello. Many types of chromatographies are here. So chromatography is used for the separation, isolation, purification and identification of components of mixture because of the distribution of the components between liquid phase and a solid phase. Nothing. Chromatography is all about adsorption. There will be adsorption. Who is going to get adsorbed? Now there is something called, because we had once upon a time surface chemistry as a part of our syllabus, which is no more a part of our syllabus now. So we are not aware of these terms, or at least it's not there in the realm of our mind right now. What is adsorbate and what is adsorbent? Adsorbate, those of you who understand Hindi, adsorbate, the one who what is bet? The one who sits. So adsorbate is the one who sits. Adsorbent is the one which is providing a bench. Adsorbent is providing a bench on which the sitting is happening, on which the adsorption is happening, right? So here you will see that if I want to separate, and NCERT was, I don't know what edition, since what number of years this line has not changed, even though so many editions, even the latest edition came so recently. Still, they like to say that this is the very new method. It is not a new method anymore. We have been using chromatography since a while, and since then there are better methods which has come. But chromatography, by the way, is relatively the newest method as compared to all other methods that we just talked about, like distillation, like separating funnel, the differential extraction, the crystallography or the crystallization process. Here chromatography is real game changer because chromatography is advancing in itself. You have very different types of chromatography, thin layer chromatography. There is a lot of different chromatographies which are there in your syllabus, like all of these. Please check. Column, thin layer paper. There is also more advanced chromatographic plates which has now come in. So there are essentially two different types of chromatography that you need to know. First thing is adsorption, which is different from absorption. So the principle at play is the adsorption here. Now there is something called directly adsorption chromatography. The other one is called partition chromatography. There is a continuous partition taking place. What is happening? There is a continuous partition. What does that mean? So there is something which is getting adsorbed, something moves up, getting absorbed, something moves up, getting absorbed, something moves up. Like in the paper chromatography, things are getting absorbed and moving up, moving up, moving up. So there is a continuous partition happening of the particular liquid that we have put on the chromatographic paper. So all the last batch students had the opportunity to actually witness this whole experiment with me, where we carried out this chromatography in the class. Today we are not going to. I'll share the shot with you. So these are the three different ones from where the question can come. Adsorption chromatography is based on a differential adsorption of various components of a mixture on a suitable adsorbent. So you can see this is the principle for the differential adsorption. You should have a suitable adsorbent. What is bent? I hope now you remember, the one which is providing the bench. What does that mean? Surface or the species where adsorption takes place. Generally, alumina silicates, all of these are going to be used in the adsorption, the thin layers. If you've ever purchased, by the way, shoes, you would see that they add the silica gel. Silica gel is a great adsorbing material. So it is absorbing that smell. You would have seen that the leather things, your shoes or the heels or whatever you have purchased, the shoes generally has a tendency to start stinking in some time. So to prevent that smell, you would see that always it comes with this particular silica, what do I say, a packet of silica, right? Similarly, you would see even the bottles with such, wherever there are hollow things, you would have silica, even the purses, leather purses, all of that. We are making use of adsorption all the time. Don't know why NT has removed surface chemistry from your syllabus. Though we have this, some components are strongly adsorbed, thus travel at a different rate and get adsorbed. So anything which is going to be adsorbed strongly, listen to this, anything which is adsorbed strongly will travel faster or slower? Faster or slower? Adsorbing strongly. Will it travel a chromatogram faster or slower? Let's imagine that there is this adsorbing material. It is strongly adsorbing this liquid that we have added. It is strongly. So if it is strongly adsorbing, it will not allow it to travel faster, right? So there can be questions which can be related to adsorption here. The applicative questions of adsorption, you should be able to realize that which is going to travel faster, which is going to travel slower, which is going to be, so if I say rate of, I will, let's say, separation of A is greater than B. Okay, rate of separation of A is greater than B. Which is the right representation? A, B, A, B. Option A, option B. Which is the right chromatogram? Which is the right chromatogram? So if I'm saying rate of separation of A is faster, it would have traveled more. Same question. So answer here will be B. Same question, I mean same options, but the question is if the rate of adsorption of A is greater than B, which is the right chromatogram? So if A is getting adsorbed, then A is the answer for this. Now I can complicate the question by giving you 4 things, right? I can complicate the question by giving you colors. Red color, blue color, green color, purple color. The rate of adsorption of red color is greater than blue color, than purple color, like that. So what is the best chromatogram that represents it? So basically it's a question of understanding adsorption to the core and be able to do the answer. Is it clear? Such questions are doable, guys? Okay. Then we'll move on. Column chromatography. Please see, mixture is placed on the top of the adsorbent column packed in a glass tube. An appropriate eluent is added. Okay, where is it? Appropriate eluent is added. What is eluent? So whatever has been adsorbed, now I can add a species. So let's say this is the color, red color that has been adsorbed, red dye that has been adsorbed. Now I can add an eluent which is going to carry it. So that means eluent is that substance which can dissolve this red dye into itself. Like dissolves like principle. It's working on the like dissolves like principle. It will take this dye, come at the bottom And here now you have this eluent plus dye. So basically it is doing deadsorption. Do you understand what an eluent does? It is going to carry out the deadsorption. Important thing is what can come in your exam. Like I said, the visual apparatus should be on it. That's why I have got it in a very creative way, so that you should know it's from the top to bottom technique, unlike paper chromatography. So if you remember, we did paper chromatography. We took a chromatographic paper. Those of you who couldn't see the chromatography experiment, I'll share that shot with you. You will be able to see it, what we did in the class. So we added water, not so much, of course. So what we did, I'll tell you that because this is important. So we'll take a chromatographic paper. We do a marking here. We put a dot here. Not a dot, I mean just a little pencil. Say there's a small mark that you put. There you are going to put, let's say, 2 sketch pens. By the way, this can work well on the toilet, not the toilet paper, the tissue paper, the toilet towels, what do we call? The paper towels. You can do it with the paper towel at your own home. It's a DIY experiment for you. So you can put 2 sketch pens here, red and blue, let's say. So if you put it here, you will see that we just took, I think, black color dye, and it got separated into various colors. I'll show you the chromatogram. It should just a little bit touch into the water. The mark is still here above the water, so it will start traveling up. So it is bottom to top approach. But here the column chromatography is top to bottom. Please observe, this is different from what we did. This is top to bottom. Whatever we have to separate, we take silica gel in this whole, this is like a burette kind of a thing, column chromatography though. We are taking a mixture here, it will go down. So the colors, the rate of the adsorption, if asked in such a setup, guys, it will change. In a column chromatography, if I'm saying, this is my column chromatography, right? Rate of adsorption of A is greater than B. Which is the right column? Right column, A, B, B, A. So your answers will change. Now I'm giving you a very simple question. They can give you various colors, A, B, C, D, such stuff. So if I'm saying rate of adsorption of A is greater than B, which is the right column? So now you have to answer thinking that we are adding A and B from the top. So whichever is going to be adsorbed is going to be on the top because we are adding it from the top. So this requires your knowledge that we are adding stuff from the top, right? Okay, moving ahead. Thin layer chromatography involves separation of components of a mixture over a thin layer of adsorbent coated. It's very same, it's just that we are making use of a chroma plate here. This is how a chroma plate looks like. This is also, it's a little expensive. This chroma plate is reusable. This chroma plate is quite expensive. This chroma plate is, of course, not like a paper. This is a plate, a reusable plate actually. So you will see that this is again bottom to top or top to bottom. This is going from bottom to top. Separation is happening. Color, you can see X1, X2, X3. That means X3 has traveled more than X2 and then X1. The distance they have traveled, please check. This is also a proper question which is possible. The question related to R factor. Very probable, it's very probable to get, okay. It's very probable to get a question from R factor. Guys, we'll still be here. 1 second, take a look. Till here the water has moved. Please check. Or whatever you are using here has moved till here. We'll call it solvent. This solvent has moved till here. This is the distance y from this marking of the pencil, by the way. And I need to find the R factor ratios. I say that this is 10 centimeter that it has traveled. We can see it from the scale itself. Let's say there are 3 different components that we have got. So this has traveled 2, this has traveled 4, this has traveled 6. So guys, can you tell me the R factor of orange, yellow and blue? What will be the R factor of orange, yellow and blue? If 2, 4 and 6 are the blue, yellow and orange, it is nothing but the distance traveled by the solvent. You have to take it in the denominator. Distance traveled by the whatever substance, whatever dye you have, the solute, and let me say. So whatever is traveling, that species, whatever it has traveled, let's say dye in this case. So the distance traveled by the dye divided by the distance traveled by the solvent. That's your R factor. So R factor will be distance traveled by your color divided by the distance traveled by your solvent. So it will be for orange 6 by 10, for yellow color 4 by 10, for blue color 2 by 10. So 0.6, 0.4, 0.2. That is something that you should know. R factor questions are quite probable, which can come from here. Distance moved by the component from the baseline divided by the distance moved by the solvent from the baseline. RF is nothing but retardation factor. All right. This is your thin layer chromatography. Thin layer chromatography. The same question is possible from the paper chromatography, which works on the principle of partition. It is a continuous differential partitioning of the components of a mixture between stationary and mobile phase. Continuously there is a partition happening between the moving phase and the stationary phase. So there is a continuous partition. That's why the name, the partition chromatography. So paper chromatography is the example, which I hope you can now understand. Looks very much like the TLC, thin layer chromatography. Very similar, guys. Check. But all that we are making use of is, instead of a plate now which has been adsorbed with silica or alumina, we have a paper here. Okay, that's what we make use of.